Okay, students, let's try this problem. So this is for practice 17.8. So please make sure you have that out. You are ready to go. I want you to actually try this on your own. So it says calculate the molar solubility of iron 2 hydroxide in pure water. So first things first, write your equation, right? Your iron hydroxide is going to break apart into iron and hydroxide. Write your KSP expression, make an ice table, then plug in to your KSP expression. So you get the KSP from this chart, you can then solve for S, and that will be your molar solubility. Please pause this video now and do that on your own, and then you can continue watching the video for the answer. Okay, so hopefully you have actually paused the video. Hopefully you have done that, and now we can work on this problem together. So it is going to be extremely messy. I do not know a better way to do this. So we are starting with our iron 2 hydroxide. We know that it is a solid. It is going to dissolve, right? Some of it will dissolve. It will dissolve into iron. Iron has a 2+ charge, right? Because we have 2 hydroxides. We know hydroxide has a -1 charge. So our iron is going to end up being aqueous. And then it's also going to dissolve into, we're going to have 2 hydroxides, right? Because we had OH2 over there. Hydroxide has a minus charge, and that is also aqueous. So this should be the expression that you've written for your iron 2 hydroxide. We can then write our KSP expression. So our KSP, so it's just like our K expression, right? It's going to be our products over our reactants. So in this case, we're going to have our iron 2 plus, and we're going to multiply it by our hydroxide, so our OH minus, and we're going to raise that to the second power. So that's our KSP expression. We can now do an ice table. With our ice table, we know that we're not going to worry about the solid, so we're only going to worry about our aqueous. So initially, we do not have any of our products, right? Those do not exist. Our iron is going to increase by S, and our hydroxide is also going to increase by S, but since we have 2 of them, it's going to increase by 2S. So at equilibrium, right, our iron is S, our hydroxide is our 2S. We can then go ahead over here and plug those in. So first, let's look up our KSP value. So pull back up the chart with the KSP values. If we do that, we find that our KSP value is 4.87 times 10 to the negative 17. That equals, let's plug in our iron 2 plus, we're going to plug S in here. And then for our hydroxide, let's plug in our 2S. Once again, that 2S is going to be squared still because we had that hydroxide squared up here. Let's walk through it step by step. So our squared is going to go in, right? We're going to square our 2, so that's going to be 4, and we're going to square our S. So that's going to be S squared. So I'm going to go ahead and just leave this number here, right? Because that number is not changing. I'm just going to put an arrow. So I'm going to have S times 4S squared. And then let me go ahead and put that S in there. So I multiply this whole thing by S. So we should get 4S cubed. And that's still going to be equal to this term, this 4.87 times 10 to the negative 17. Now we need to solve for S. So let's go ahead and get S by itself. So we're going to divide each side by 4. So if we divide each side by 4, we get, let's see, so this 4.87 times 10 to the negative 17 divided by 4 is 1.22. So make sure you plug this in your calculator. Actually try this. 1.22 times 10 to the negative 17. That equals s cubed. Okay, we still need to solve for s, so let's take the cube root of both sides. So I take the cube root of both sides. Make sure you know how to plug this in your calculator. So now we just have solved for s. So s equals 2.3 times 10 to the negative 6. That is terms of molarity. So the most amount of iron 2 hydroxide that will dissolve in water is 2.3 times 10 to the negative 6 molar. That is all that will dissolve, okay? That is at some certain temperature. That is when we are in water. We know that only 2.3 times 10 to the negative 6 moles will dissolve in 1 liter of water. Stay tuned for the next video.